Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Yeah, thank you very much for Dr. Muhammad Noor Jalil. How we can call you, Dr. Muhammad or Dr. Jalil?
Dr. Muhammad No,
Oh,
because
Dr. Muhammad.
my name is Muhammad No and Jalil is my father's name.
Oh, I see, I see.
Okay.
So, Dr. Muhammad, thank you very much, Dr. Muhammad, for the speech that we will have today. It's all about the electrochemistry, and here we have, I think, most of the students from the uh, materials chemistry lecture. So we have materials chemistry lecture for this semester for the new students. So this is the second year students, and we have 4 classes. I am one of the teacher, and Dr. Amalia, Dr. Amalia, no, not Dr. Ray yet. Mrs. Amalia, and then Mr. Hanifuddin, Miss uh, Mrs. Dr. Asa, sorry, Dr. Asa, and Mrs. Fani Amita. So we have not 5 classes. Sorry, I'm sorry, 5 classes. So we have the new students, the second year student, second semester student. Sorry, second semester student, and they are now in materials chemistry course, and one of the materials chemistry course about the electrochemistry. So this topic is correct for them. And also we have probably some other students and some lecturer from other university and all, or from other department at ITS. Before we uh, have your talk, I would like to share your CV so that we will introduce you to the students and also all the participants. I will share the screen. This is the CV that you have already shared to Mrs. Malia. Sorry. So I don't know the SPKS. I think this is
This is
this is
the
yeah. What is it?
because I am involved in the police.
Oh,
Part of me is police,
oh, I
police, and
see.
part of me and another part of me is a lecturer.
I see.
So DSP is a what's it called, pangkat, is a
Yeah.
title, is a deputy superintendent police.
Oh, superintendent. So are you also a police officer?
Half half.
Half. Oh, okay.
It's like a frog, frog.
Yeah, in our unit, in our country, it's called perwira karir. Yeah, it's not
It-
from the police, but from other, for example, like engineer or doctor, but they have career in the army or in the
oh, okay,
police.
okay, okay.
Is it same like that?
I think it's the same. I think it's the
Yeah.
same.
Okay. So Dr. Muhammad Nur Jalil,
TS is
Academic Kepolisian, yes.
TS is a technology, and CHM actually is a chemistry.
Oh, this
Uh,
is the doctor, like this is like the PA or no?
I'm not sure, but it's a technology. It's
Technology.
recognized by my country. It's
Okay.
one of the professional technology, and CHM is one of the chemists.
Oh,
Okay.
in our in our sorry, in our country, probably like engineer.
Yeah, it's similar like to engineer. IR is for engineer.
Yes, IR.
Uh, it,
Okay,
but this
this is
one is for chemist.
from Akademi Kepolisian,
Yeah.
UiTM, PTRM, Fakulti Sains Gunaan. So this is like engineering faculty, faculty of engineering, yeah, science,
Yeah, Sains Gunaan is applied sciences.
applied science. Okay.
Applied sciences.
University Teknologi Mara in Selangor, Malaysia.
Yeah.
So the position is the Police Academy, the director of UiTM PTRM Police Academy and lecturer. And this is the email. Probably if some of you want to send email to Dr. Muhammad.
Yes, please send
Uh,
email if you want to ask, or you want to be my future student
yeah,
for PhD or master. Please.
okay. So this is the cell phone, I think the mobile, yeah. And this
Yeah.
is the office, office,
Office.
and this is the fax. This is alternative email, and this is the area of specialization, the electrochemistry and porous material application, PhD from the University of Manchester, UK. 2010 about the preparation of mesostructural thin film for electrochemical application. MSc from the UTM. I think we also have staff here graduated from UTM Malaysia.
Oh, okay.
Pak
That's
Hosta
good.
ya? Pak Hosta itu UTM ya? Bu Ahmad Bu Ail, UTM. Johor, right?
Yeah, in Johor.
Oh, Pak Agung Kurniawan. Pak Agung
Okay.
Kurniawan from UTM, but mechanical engineering.
All right, all right. Yes.
Mechanical engineering and PSC from UTM also. I have ever uh, gone to UTM for the conference, I think in 2019, before
Okay.
the pandemic situation. Yeah, UTM. I have already been there. UTM. And this is the awards and the achievement. Many. I think we will not read all. It's very, yeah. It is the research and publication. You have already written a book about the thermodynamics, and then this is the journal in the Malaysian Journal of Analytical Science and many more. And this is the expertise, the consultancy for the government and other expertise in the academic, I think, yeah,
Yeah. Yeah.
conference and many more. Okay, it's very uh, more. So if we read all, we need more time. So I think that's all that we can introduce Dr. Muhammad to the audience. Now it's your time to present your talk about the electrochemistry. Okay, you can start, Dr. Muhammad. I will stop my screen. And for the students, you have to add the presence and the, Mrs. Amalia will share the link to you at the chat. Okay, please, Dr. Muhammad, time's yours.
Okay. Thank you very much, Ibu Diah. I still find where is to this one is share screen. Okay. Share screen. I need to share screen first. Okay. Can 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 you
Yes,
view
we
my
can.
screen here?
Yes.
Okay. Thank you very much. Okay. This is me actually. This is me wearing the we call it jubah, which is coat from University of Manchester. Uh, so my name, as Ibu Diah said just now, is Muhammad Noor bin Jalil. Muhammad Noor is my name, and Jalil is my father's name. But when I study in UK, they call me Mr. Jalil. You know, in UK they use surname. It's not the real name. Okay, all right. So first of all, I would like to acknowledge the organizing committee of guest lecturer series department base, our moderator, Dr. Diah Susanti, Dr. Amalia, I think here, Dr. Hanifuddin, and so forth. Institute Technology 10 November, and also I would like to acknowledge University Technology Mara and also my beloved Faculty of Applied Sciences. Uh, this is my introduction. My topic is actually electrochemistry and corrosion science. And my objective is only for undergraduate student. If the audience come from masters or PhD, it might not suitable because of this is a basic electrochemistry and also the basic corrosion science. It's just to give you the view of what is electrochemistry, what is the corrosion, and what is the use of electrochemistry. Why electro plus chemistry? Okay, so I divide my talk today. I can share not my talk. I can say it's a sharing session into three parts, which is the part A is electrochemistry and basic principle. If you want to understand the corrosion, you must understand the electrochemistry basic principle. The second part is part B is application of electrochemistry. So when you go home, you if you go to the mall, if you see something, then you think about electrochemistry. This is the part B, application of electrochemistry. As you know, that electrochemistry is everywhere around you. They use electrochemistry. Just that you don't know they use is electrochemistry knowledge. And the part C is a corrosion science. Okay. Next is part A. Part A is about electrochemistry. I try my best. How long, Dr. Diah? I have time. 1 hour, 1 hour, 30 minutes.
Uh, 1 hour and 30 minutes. Mrs. Amalia, yes?
Okay, all
Yeah.
right. Okay. I try my
Yes,
best to finish in 1 hour and 30 minutes
yes.
and plus the question and answer. So for the student,
Perfect. Yeah.
if you want to ask question, just ask question. Just ask question and to Dr. Diah or Dr. Amalia, then I will answer straight away. Rather than wait until the end and your question will be evaporated. Okay, what is electrochemistry? So electrochemistry, in words, in the beautiful words, we can say that it's interconversion between electrical energy and chemical energy. Interconversion means that electrical energy change to chemical energy, or chemical energy change to the electrical energy. This is interconversion. And the conversion of the electrochemistry take place in the electrochemical cells. You must have cell or system, this system. You must have this kind of system because electrochemistry only happen in the electrochemical cells. Can be happen in outside electrochemical cell? Cannot. It must have electrochemical cells to be occur. And another thing is that the must thing is that in electrochemical cell, it must have reaction in terms of reduction and oxidation. What happens if oxidation, only oxidation occur? There is no electrochemistry. Or reduction occur? There is no electrochemistry. Both reduction and oxidation must occur in the electrochemical cells. This is very important. Okay, what is corrosion? Because my topic is it talk about corrosion. So what is corrosion? Corrosion is branch of electrochemistry. So what is electrochemistry? It's a branch of chemistry. So chemistry, his kit is electrochemistry. Another and electrochemistry kits is the corrosion. So what is corrosion? Corrosion, normally people refer to the rusting of iron. You can see this car. I don't know. This car is produced, I think, before I actually born. This is about 60 or 50 years ago, before I was born. So you can see that rusting all over the car. Okay, and the rusting process need oxygen and water. So in corrosion, normally it can happen another way, but normally we can say normally when in the system have oxygen and water, and it must have a corrosion. Okay, let's start with the basic thing first, electrochemistry. So in electrochemistry, like I uh, said just now, is about electrochemical cells. Electrochemistry must have electrochemical cell. How about electrochemistry without electrochemical cell? There's no electrochemistry. Simple as that. So electrochemistry cell must occur to electrochemistry to happen. So in electrochemical cell, they have four essential components. You must have anode, you must have cathode. This one cathode. How I remember this one is cathode? Because in Malay, in Malay we said cathode is cathode. There's T there. Cathode. T is tolak. So tolak means negative. So this is cathode. So this is anode. So cathode, anode, electrode. It must have ionic conductor, and also must have, sorry, ionic conductor is here. It's in the liquid. And it also must have metallic conductor, which is here, metallic. So these four components must exist in electrochemical cell. What happens if one of them missing? So if one of them missing, there is no electrochemistry. There is no electrochemical chemistry cell. There's no uh, any reaction of electrochemistry. So these four essential must occur, must present if electrochemistry cell uh, want to exist. Okay, so electrochemical cell itself, you can divide it into three category. The first one is galvanic cell. The second one is electrolytic cell. The third one is concentration cell. So just continue because my slide actually is 134. If I can finish within half an hour, try my best. Okay. So what is a galvanic cell? So this is galvanic cell. Okay, galvanic cell, there is no, this is only voltmeter. This is not a battery. Galvanic cell is only uh, two electrode and also voltmeter. Let let finds the that's one. This one is also galvanic cell. See, you have two electrode and voltmeter. What is the voltmeter? Voltmeter. Voltmeter. The purpose of voltmeter here is to measure the current. You know when electron move inside the metallic conductor here, so it produce current. So voltmeter will measure current. So this is a galvanic. There's no battery or power provided here. So it means that the system, this system provide energy, move electron through the circuit. Okay, that's a galvanic. This one is a galvanic cell. So sometimes people says Daniel cell or Daniel cell. In fact, in my country, some of the parents name their children as a Daniel. I don't know about that. Maybe they study electrochemical cell before. So Daniel cell. So this is a I don't want to go in detail in this thing, but basically in the galvanic cell, the system here, the system down here, produce current, voltmeter, and this system occur spontaneously. So you don't do anything, this spontaneous happen, they give you a current. Okay, all right. So another thing is electrolytic cell. So the difference between galvanics and electrolytic cell is that you have a battery here. Sorry, what is the purpose of battery? This is switch in on and off. It doesn't matter. This is bulb. Bulb is to ensure that current flow in the outside circuit. So what is the battery? The purpose of battery here. So battery here, the purpose of battery here to provide the voltage to move electron into the out circuit. This is out circuit, and in the electrolyte we call it in a liquid circuit. So this is out circuit. So battery is used to move electron. Okay, compared to the galvanic, the system is moving the electron. So this one, the battery itself move an electron. Okay, so comparison between component of electrochemical cell. So galvanic produce chemical energy. So chemical energy, so the system produce chemical energy from chemical energy to electrical energy, which is current, and electrolytic cell provide electrical energy, which is battery provide the current to the system. So spontaneous forced reaction because you have battery and battery is a forced reaction. This one is a spontaneous reaction. What is spontaneous and forced reaction? Spontaneous happen automatically. You set the system, it's happen. It's like if you have a mark of Milo on the table, and suddenly a mark of Milo gone. It's not spontaneous. Somebody took it. This is forced reaction. Spontaneous reaction is something like it's happened, just happened. Okay, positive. This one is a positive cathode, negative cathode, negative anode, positive anode. Because of what? Because of the refer to the battery N. So let's say this is negative and it's positive. So if negative here, it must be negative here. So this is a little bit of comparison. And the last one is that, where Where is the last one? Electrical cell, galvanic cell, electrode cell, concentration cell. This is not. Where's the concentration cell? I think I've been deleted. Doesn't matter. Okay, the last one is a concentration cell. This one, concentration cell. So concentration cell is actually is a same thing as here. It's just that let me show you. It's just that same thing is here. Electrodes is the same. Let's say this is zinc. This is also zinc. The difference is that concentration here and concentration here is different. Let's say this is zinc sulfate, 1 molar, and this is also zinc sulfate, 5 molar. That's the concentration different. So the system, actually the nature will make both of them equal. So how to make both of them equal? So electron will flow from the electrode to the another part. So it makes the system equal. That's a concentration cell. Because I put it here just now, I think I might be delete that slide. It doesn't matter. It's okay. So another important things in electrochemistry is that the standard electric potential. So what is standard electric potential? Okay. Before I explain far about this topic, I want to show you something. This is, we call it standard electrode potential, or sometimes we call it standard reduction potential. You can Google it. You can go Google it. You just type in Google standard reduction potential. They will give you something like this with this number. So what is this? Where this number come from actually? Let's say fluorine plus 2 electron become fluoride aqueous plus 2.87 E0 chlorine, something like that. Where this number come from? So where this number come from is come from here, standard electric potential. Because actually nobody knows what is the standard potential for zinc, copper. Nobody knows. So what happened? Scientists refer to something else. So what they doing is that according to IUPAC conversion, half reaction are written as reduction. So the standard electric potential is sometimes called a standard reduction potential as redox potential. They build the electrochemical cell like this. This is a galvanic cell. The electrode potential measured under standard state condition. They put a standard state, which is this one. Standard state condition, which is temperature 25, pressure 1 atm, concentration cell. Concentration of the cell is 1 molar. So they compare. So they compare. Let's say this is zinc. They compare with this one, this hydrogen potential. So they, like I said it before, in electrochemical cell, it must have two, oxidation and reduction. They must have two electrodes. They cannot be one electrode. Cannot be. It must have two electrodes. So one electrode is hydrogen electrode, and another one is the metal that they want to compare. In this case, is zinc. So zinc compared to hydrogen. What is the voltmeter reading? What is the voltmeter reading? So, and they change zinc to copper, zinc to plumbum, zinc to so many things. So they get some reading compared to hydrogen. So at the end of the day, you can see that hydrogen here is 0. So everything here is actually compared to the hydrogen electrode. Hydrogen electrode. Hydrogen electrode. So if you have copper electrode, and then the second one is a ferrum electrode, so you can get plus 034. So you can ferrum, you can get not ferrum here, ferrum 2 to ferrum 3. Okay, lithium. Let's say for lithium, which is It's quite impossible. Natrium is quite impossible. But let's say you have lithium electrode, so you get copper electrode, so you get a battery which is plus 34 and plus 3. You can get a 339 voltage, 339 voltage, because you have to plus here and also plus here. So this is why the standard electron electrode is so important, because of you want to know in theory and in experiment. In experiment, you have two electrode, you put it inside the electrochemical cell, you measure the E naught. The E naught is electrical energy. In standard, not here is zero, here is means that in the standard condition. So you can get the actually a basics knowledge about a basic view about the electrochemical cell itself. So this is the basic one. Okay, another thing is that it's a cell notation. You know, for scientists, they don't if you want to present electrochemical cells, they don't draw this kind of cell. They just make it simple, something like this. Sorry, something like this. This is called cell notation. Okay, cell notation. This is compartment for anode, and this is compartment for cathode. How they do it is that like this. So if you have electrode zinc and you have electrode copper, and this one is a ion which is involved in the reaction, ion zinc and ion copper. Can you change the zincs with another things? Yes, yes you can. Let's say even though you use electrode zinc, you can use here maybe ferrum ion or something else. It's just that either the cell is possible to produce electric or not possible to produce electric. But the cell notation is used to represent the electrochemical cell. So this one is a phase boundary. The electrode is a phase boundary between solid and ion. This one is solid and this one is an ion. And it's a salt bridge of porous position, partition. Salt bridge, or sometimes they just use partition. Okay, for that basic electrochemistry, do you have any question? So far okay, or I want to continue? Do you have any question?
Question from students? Hello? I think no question, Dr. Muhammad.
Okay.
Can continue.
Okay.
Yes.
Thank you very much, Ibu Diah. This is the basic one. Actually, there is a detail on this thing, but in the particular sharing, I cannot go into detail. If you want more detail, especially for masters and PhD student, then you can call me or email me. It's okay for me. Okay. We go to another topic is how do electron move in electrolysis or electrochemistry? How do electron move in electrolysis? This is another question. Electron doesn't move, doesn't swimming inside the electrolyte. It doesn't. So what happened actually? Electron only move in the outside circuit. Electron move in the. This is from Quora website. You can Google it. This one, and what happened in the electrolyte? In the electrolyte, electron doesn't swimming in electrolyte. What happened actually is the ion is moving toward the electrode. Ion, let's say this is copper. Copper moving towards this metal, and sulfate move to this copper. So it's considered complete circuit. Because of what? Because of like this. This is negative. So this is negative. So electron is taken up by the copper. So it seems like electron being taken up. So electron must move here from here. So where is the electron come from? It must come from here, copper. So sulfate goes here, release some of the electron. So electron move from here, goes to the battery and take up by the copper. So you can see the yellow line here. is a deposition of copper. This is what happened in the electrolysis or deposition. This one is copper deposition. Okay. Next is how do electron move in electrolyte? Cell again, phosphate battery. So actually, I already answered this question. They don't swimming in the electrolyte. The ion is moving in the electrolyte. Actually, it's the same thing. So next question is how does electric conduct in solid and liquid? Uh, Another question, but the answer is still the same. See, electric is move of charge. The charge is generally carried out, blah, blah, blah. Conductive liquid dissolve ion. So ion, again, move. So the three questions with the one answer. Okay. So I continue into the part B, which is application of electrochemistry. So in the part one, actually, uh, let me reverse back. So the part one, you can calculate how many copper, how thick is the copper deposit in the electrode of cathode. Let's say this is cathode. So how thick is the copper here? You can calculate by calculating the amount of electron moving towards to the copper ion. So you can calculate. There is a formula you can calculate. Then from that calculation, in theory, you can calculate how thick is the copper cover the electrode or the cathode. Okay, so we continue with the application of chemistry. So this is some of the application of electrochemistry. You can do sensing, you can do energy storage, you can do conversion of energy, energy conversion, industrial electrolysis, organic electrosynthesis, and corrosion. Honestly, electrochemistry knowledge is an old knowledge. People know the theory of electrochemistry, I think 100 years ago, 200 years ago. But what is new in electrochemistry is the application of electrochemistry. Like in sensing, they used to sense something using the knowledge, the basic knowledge of the electrochemistry. Energy storage and so forth, and so forth is using the knowledge of electrochemistry to get something else. That's a new one. But electrochemistry itself, the theory, ion, electron move in the to cathode, cathode electrode is an old knowledge, and people have been teaching this kind of subject years ago. Okay, doesn't matter. So the first one, sensing. Okay, sensing. So application of electrochemistry for sensing. This is one of them. Sensing. What is this? I don't know about in Indonesia, but in Malaysia, almost I can say 4 or 5 family, one of 4 or 5 family have this kind of device. What is this? This is glucose sensor device. This is glucose sensor device. I can buy this kind of equipment around, let's say, 100 ringgit Malaysia. I don't know about Indonesian rupiah, but in Malaysia we can get it as cheap as 100 ringgit, or you can buying a cheaper one using the online shopping. So this is the glucose sensor. So what they do, but this kind of instrument do is that they can sense the glucose concentration in your blood. I think in Malaysia, one of 3 people, one of them has the problem with diabetes. So it's quite pandemic here. People in Malaysia, I think they have a lot of eating habit. So they don't exercise. At the end of the day, at the age of 50, they get diabetes. So how to sense the glucose level or sugar level in your blood? Rather than going to hospital, you just buy this kind of machine. It's about 100 ringgit. Then you can take some blood. There's a tools to take some blood, only a little bit. Then you can sense the sugar level in your blood. So this kind of machine is apply the electrochemistry process, whereas this one is the first generation, second generation glucose sensor, the third generation glucose sensor, and this is the fourth generation. Nowadays people are using this theory, no longer this one. It's quite long. So you can have glucose, and glucose reduce, no sorry, oxidize, glucose to oxidize. When something oxidize, it must have release some electron. So that kind of electron being sensed by the machine. So so anything lose or lost their electron is oxidation. So if something oxidized, they must have reduction in electrochemistry. You cannot only, you know, oxidize. Then what happened next? No. Anything in this world, in this world, not afterlife. I don't know afterlife, but in this world, in the physical world, anything that oxidize, they must have a partner. Another thing is reduce. So oxidize means release the electron. So somebody must take the electron. So during the process, an electron being taken out by the machine and count how many electron they have. Let's say 2000, 2000 electron. So 2000 electron is a compare what is the 2000 electron means. It means that your glucose in your blood is 6, 7 millimole, 9. Actually, 4 to 6 is a normal for a normal person, which is without diabetes disease. If you have more than 6, let's say 7, 8, 9, 10, 11, or no, no count, it means that too much glucose in your blood. So this is one of the application of this is area of research. You can go into the research. So what kind of research that you can do is that you have to find the enzyme, suitable enzyme of to produce this kind of uh, sensor. So you can refer this one is from Division of Diabetes, Endocrinology or Metallurgical Faculty of Medicine, College London. This paper was published 2009. Okay, another thing is that electro application is that energy storage. So this is normal. If you talk about electrochemistry, then you have talked about energy storage or energy conversion. The simplest one is a battery. Battery, you use battery every day. You use handphone, you have cellular phone. You use a battery for moving your clock, your watch is a battery. Battery is a electrochemistry application. What is battery is all about? Battery is a single battery. Actually, is a one galvanic cell. So remember just now I talked about galvanic cell. Battery actually is a galvanic cell. You cannot see the wire, messy, because a battery has been compact into one compartment, which is a very tidy and compact. So it becomes battery. Battery is a galvanic cell actually. What does galvanic cell do? Galvanic cell from the system produce electricity. That's a galvanic cell. Okay. Uh, this one battery has so many kind of battery. This is a lead battery or plumbum battery. Lead is plumbum. Uh, it's lead battery. Lead battery where you can find it in the motor car, in the lorry. They have some battery and they use lead battery. Normally they use lead battery. But nowadays lead battery still available, but people who has a lot of money they buy the lead battery, but they don't use the electrolyte. Uh, they change the electrolyte. Previously, people used 38% of sulfuric acid. Electrolyte, we call it here air battery. Air battery. It's a water battery water. Actually, it's a sulfuric acid. So if you don't want to buy the battery water from the shop, you can make it by yourself. 38% in the lab. You just make it in the lab, then put in your car. It's the same thing. But nowadays, they change this liquid into gel form. It's still sulfuric acid, but sulfuric acid in the gel form. So this is lead battery. This is also a battery. This is how it goes. So a lead battery is galvanic cell. So what is this? So lead battery actually is galvanic cell. Then in when you charge the battery, uh, it's become another cell, another kind of cell. This one. So at first, uh, reduction here, uh, plumbum to plumbum sulfate reduction, and when you charge it, plumbum sulfate turn to the plumbum oxide. So actually, this is a circle of process of charging and discharging. Charging the system give your current to the, this one is a bulb, lamp bulb, and charging you give some energy to the battery. So this is zinc dry cell. It's a battery like this. I don't know what kind of battery in Indonesia. So Energizer is one of the famous battery brand in Malaysia. So Energizer, this is the cheapest one. The zinc dry cell is the cheapest one. So they have zinc as electrode and manganese oxide as the cathode. So it must have, because of zinc dry cell is electrochemical cell, so it must have the four things: uh, anode, cathode, electrolyte, and also the wire, the outside circuit, solid circuit outside system. So this is zinc dry cell. So what is different between the first one, lead, is they change the electrode and also the electrolyte. They use base, natrium, sodium hydroxide, calcium hydroxide, or zinc oxide in term of base. Okay, you can also have mercury dry cell. This is a battery normally used in your watch. Your watch is in this kind of watch. They don't produce this in a bigger scale. They use in this small, tiny battery. So another thing is that the lithium ion battery used in your cell phone. They have anode, cathode. Why they call it lithium ion is because the battery contain lithium salt, the ion. And this is a kind of research that you can pursue for your masters and PhD. You can study lithium ion, how efficiency of lithium ion, and so forth. And also this one, dry cell. But people now is going to lithium ion because lithium ion more efficient. You know, cell potential what 3.0 volt. This is quite high. This one also things that you can venture. This is a fuel cell. So in this thing is that you are using, let's say I move this one, hydrogen and oxygen. So hydrogen, oxygen combined together, you get water. Isn't that isn't that water is a combination of hydrogen and oxygen? So hydrogen and oxygen. So this is hydrogen become acid. This one plus two electron, zero. This is from reduction potential table, and this one 2H plus oxygen plus two electron, you get water. So if these two can be combined together, so uh, the direction is must have the other word. This one is oxidation. This one is reduction. Okay, or this one is reduction. This one is oxidation. Depends. This one is both. If you can see here, this is both in a way of reduction. This one is both on the reduction. So if you have hydrogen and oxygen, you can combine it. So there's energy occur and electron is moving, so you can get electric. So this is we call it fuel cell. And I think about 20 years ago, the 20 or 30 years ago, people start to venture on this kind of research. Okay. This is another things where electrochemical manufacturing in the chemical industry, electrochemical manufacturing in the chemical industry. So one of the so many things is one of them. We call it the chlor-alkali manufacturing. What they manufacture? They manufacture chlorine gas and also hydrogen gas. It's easy actually. It's a simple cell. You have brine. Brine actually is a sodium chloride or NaCl, which is garam, which is a salt that we table salt. In NaCl is table salt. You can use NaCl in your food. So what happen if you have a liquid NaCl? Then you put some electrode. You put some electrode here. You put some electrode. Then you give some energy battery. This particular uh, liquid will produce chlorine gas and also hydrogen gas. Actually, this simple reaction being used by huge manufacturer to produce chlorine gas and also hydrogen gas. So what is the use of chlorine gas? So many things we can uh, apply chlorine gas, such as in your soap, in your shampoo, in so many things. So chloroalkali product as a precursor adhesive to make plastic, to make paint, this disinfectant. Uh, if you want to clean your toilet, you have to use the powerful disinfectant, powerful soap, water additive, rubber, cosmetic, and so on and so forth. Actually, fuel additive also use chlorine. So as easy as this setup for electrochemistry, you can get chlorine gas. Another one is that this one is a brine. Brine means that liquid NaCl uh, in aqueous phase. This one is the bottom one is here is actually is the NaCl and calcium chloride. This one is a molten. You melt the salt, table salt. We have table salt. You melt it until it melt. You put some electrode, cathode and anode. Then what you can get is that is a sodium metal, natrium metal, and the other one you can get is that uh, chlorine. Here you can get chlorine. You can get natrium metal. So you can use natrium as a battery or something else, and you can get also chlorine here. So what I mean is that you can use the simple setup for electrochemistry. You can get valuable substance which is used in your everyday life. Another thing is that aluminum production. Aluminum production also using the electrochemistry. You know aluminum to make your window, aluminum window. I doesn't mean that the glass is made from aluminum. The glass is glass. I mean that the frame of your window. So what happened actually is that this is the electrode. This is electrode. They melt the ore for aluminum. Bauxite. Bauxite is the ore for aluminum. So they melt the bauxite. Then they put electrode. The aluminum will be reduced from aluminum 3 plus to aluminum. Because why? Because aluminum 3 plus get electron from the electrode, from the cathode, combined with aluminum 3 plus and aluminum reduced to aluminum solid, they can get aluminum. So in this diagram, they use alumina. Alumina is a bauxite, is alumina actually. Okay, another thing is using electrochemistry, you can go for organic electrosynthesis. Remember that even though oxygen and hydrogen, if you combine, it must have involved electron transfer. if something involves proton transfer, means that you can able to use electrochemistry to make possible the reaction occur. So in this case, they want to produce this kind of material, so they put some electrode to make this kind of material. So this is one of them. There's so many organic synthesis use electrochemistry. What they do, just they put electrode, anode and cathode. They give some voltage, give some current. Then they measure how efficient is the current. What is the current? What is the best current to give for the reaction? So another thing is that photosynthesis. You know photosynthesis. I think everybody should know this. Photosynthesis is the main reaction, the main component in the plant. So what happened in photosynthesis is hydrogen, uh, water become oxygen, carbon dioxide become glucose. So in photosynthesis also, when water transform to oxygen, and CO, carbon dioxide transform to the glucose, it involves the process of electrochemistry. So this is a electrochemistry part. You can see here. This is if we can. This is a diagram of leaf. This is a simplified diagram of when researcher uh, try to mock the what happened in the leaf. You can see that here is the electrode, and here is electrode where water turn to oxygen, and carbon dioxide turn to glucose. So actually photosynthesis process is involve electrochemistry. So why photosynthesis process involve electrochemistry? Because of there is electron change between another compound to another compound. There is a things that being reduced, there is a thing being oxidized. That's why it's called electrochemistry. Okay, so far, any question? Any question? Is that okay?
Hello, any question from students?
Okay. If you maybe it's a new for all of you, but like I said before, electrochemistry is not a new knowledge. It's been taught in university years ago, maybe 200 years ago, 300 not 300 200 years ago. This knowledge it's been there, but the new thing is that is the research using applied electrochemistry. You use electrochemistry to make something else. That's a new one. Then after you graduate from degree, then you can go venture another thing. Like myself, my PhD is about thin film. Thin film. I deposit gold on the glass and use glass as an electrode. So I deposit gold on the glass, and after that, at that time, to buy a pure gold is too expensive. So I make it my electrode myself. So I deposit gold on glass. And after that, I use gold glass as an electrode. So which is good. And from that, I study. Another thing is that I study the porous material on the surface of electrode. So what is the negative, what is positive, and that's why I managed to, at the end of the day, I managed to get my PhD. It's about 10 years ago. Okay, so the last part in my talks, actually, is I've been talking about almost 1 hour. Okay, corrosion. So corrosion is a part of electrochemistry. So apart from corrosion, you have so many things. Apart from corrosion, you have I can see this one. This is application of chemistry. So corrosion here, corrosion is part of the electrochemistry. So why people eager to know about the corrosion? Why? You must have good things to eager about the corrosion, because of corrosion happen every day. It costs a lot of money. Corrosion, people to try to avoid corrosion. You know, if you buy the motorcycle, I don't know, in Indonesia they call it sepeda, sepeda. So if you buy a motorcycle, then it, is it true, Dr. Dia? They call it
Seped
motorcycle,
ya,
sepeda,
sepeda motor.
sepeda motor. Ya.
Ya,
You
kalau
buy
sepeda yang bicycle.
satu lagi sepeda bicycle. Sepeda
Ya,
motor is a motorcycle.
yes,
Sepeda only sepeda is a bicycle.
yes.
All right. So you buy a new bicycle. After 2 years it's corrode. Nobody want it. But it's happened. And it's happened. Why it's happened? It's about galvanic cell. It's about galvanic cell. Remember remember at the beginning of our sharing session, I tell you about three types of electrochemical cell. One of them is galvanic cell. Galvanic cell sometimes is good when it's going to be a battery, and sometimes it's bad when it goes to corrosion. So because of galvanic cell here, this is the one of the pipe. I'm very sorry because most of the picture here I just take from the Google, so you can get so many picture there. Nice picture. So this is one of the pipeline. Rusty, say rusty. Bad, very bad. This is a, they don't put any corrosion inhibitor to protect the pipe. It's too bad. Not supposed to be like this. Okay, what is corrosion? What is corrosion? This is the old shipwreck. Old shipwreck. I think this ship emerged from the sea when the low tide, and you can get this kind of shipwreck. This is old shipwreck. So what is corrosion? Branch of electrochemistry, of course. Corrosion is oxidative deterioration of metal. So corrosion normally refer to deterioration of metal, refer to metal. So how about people say that your mind is corrode? No, it's not corrosion. It's corrode means it's something else. Your mind is getting bad. So corrosion only in electrochemistry is refer to metal. Metal. Only metal, remember? Not your brain. Your brain is corrode means that your brain is going bad by something else. So rusting of iron, and normally corrosion refer to iron. Iron because of what? Because of most of the thing in our daily life using iron or uh, iron plus something else. But normally it's iron, made from iron. Uh, and both to corrode the iron, you must have oxygen and water. And corrosion actually is a tiny galvanic cell. Tiny galvanic cell. Remember that? Tiny galvanic cell because of it's from a water droplet. So you get a sepeda motor, and suddenly you let the sepeda motor outside your garage. Then the rains fall down. Your sepeda motor, your motorcycle covered by the rainwater. You know rainwater in Malaysia or in a urban place is not actually, it's a water, it's a sulfuric acid. It's a low concentration of sulfuric acid. Okay, let's continue. This is what happened. This is corrosion, and this picture also I get it from the internet, Google. Corrosion. What happened actually? This is one droplet, a tiny droplet on your. Uh, this is iron metal, iron. Let's say it's iron. So what happened is corrosion. First of all, remember that this is a galvanic cell. So remember that this is galvanic cell. So galvanic cell must have what? Must have anode and also must have cathode. Because electrochemistry must have that, anode and cathode. What is the another thing is that another two things is that this is a metallic conductor, which is iron. It's a metallic conductor, and also electrolyte. This is electrolyte. This is electrolyte. So this kind of setup is a galvanic cell, and electrochemistry can happen. So what happened is actually oxidation is ferrum. This is oxidation. What is oxidation? Oxidation release their electron. So ferrum anode release the electron. Where the electron go? It goes to the cathode region. So electron goes to the cathode region. Why this one become cathode and why this one become anode? So you have to remember that the place where oxygen is depleted, depleted means less oxygen become anode. Remember that concentration cell? Concentration cell happen when the concentration of anode and cathode different. So concentration cell here, concentration here different, and this part. So one part become anode and one part become. What happen if the concentration of these two is the same? Electrochemical cell is not occur. So it's occur because of the concentration of oxygen here is higher compared to here, become anode region. This one is cathode region. So electron move from here, ferrum ion, from ferrum metal. When ferrum oxidize, they swimming, let's say, swimming, they jump into this pool of water, become ferrum 2 plus, and electron move to the cathode here, and the cathode take the oxygen, take the electron. So oxygen take electron, and also the hydrogen ion and the electron, and get water here. So this is a process of corrosion, the simplest process of the corrosion. So ferrum 2 plus going into the water, electrolyte here is water, become oxygen again, you get ferrum 3 plus, then ferrum 3 plus plus the overall from ferrum 3 plus, you get another water, you can get this one is rust, ferrum 3 plus plus oxygen, this is a rust. Rust is a corrosion product, and normally the rusting, the color of rust is like this. It's like this. This is rust. This is rust. So uh, it's like this. Okay. Corrosion and its control. How corrosion happen? Corrosion happen normally because of water and oxygen, of course. Corrosion is enhanced by the presence of impurities. If you have a pure iron, 100% pure, it's less able to corrode compared to the uh, uh, iron with impurities. If too much air and moisture, air means oxygen, and moisture means water, you have electrolytes. It can enhance, depends kind of electrolyte. You have stronger electrolyte, like say NOH, sulfuric acid, or you stay in the town, in the town you have rain. Raining in the town is much dangerous compared to raining in at the rural area like kampong, rural area. So in the town you can get acid rain. Strain in metal like dan, scratch is also uh, help in the process of corrosion. So this graph showing that temperature also. If the temperature is very high, then you can easily corrode compared to low temperature. Okay, corrosion. So even though corrosion is about electrochemistry, but corrosion can also happen without the electrochemistry process. I call it as a dry corrosion. Uh, what is the difference between dry corrosion and wet corrosion? So dry corrosion normally they just happen uh, in situ, means that it's happened at that particular place. Okay, It's involved direct chemical attack. Let's say CO2 attack. Remember that. I don't know how to uh, the correct word in Indonesia. You know, when you have a sharpener, you have a pencil and you try to sharpener, and there is a blade inside the sharpener, right? There's a blade inside the sharpener, and the blade is made from metal. You know what? My 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 mom said, don't ever blow the sharpener. You just blow, something like that. Just blow it, and at that particular time, your sharpener become no longer sharp, no longer sharpener. it, it no longer sharp because after that, after you blow it, then you take your pencil and you try to sharp again your pencil. It doesn't work because of what? Because of you blow a CO2. You know, you blow a CO2 on the surface of metal. So your sharpener become dull. Your sharpener become corrode. So the edge, the sharp edge of your sharpener become corrode. Then your sharpener no longer sharp. If you want to try an experiment after this class, you can go to the shop and you buy a new one sharpener, then you blow it. The one without blow and the one when you blow it, blow by your own breath. Don't use people breath because maybe it smells something else. Use your own one. You blow it, blow so many times, then you try to sharp your pencil, and it's not no longer sharp. It's become dull. Okay, oxygen also make if you blow oxygen into the surface of metal, it's definitely, you know what, metal want to oxidize, they need oxygen, and oxygen on the surface of metal, definitely they will grab the oxygen and become corrode. This one is H2S. This one is a sulfur oxide. Sulfur oxide. This one is a H2S. Halogen, moisture, organic acid on metal. Inorganic acid on metal. So this is happen what? This happen why? If you have like a knife, you have a knife, very sharp one, and you always use it to cut something sour, sour plum, something sour, something acidic, like to cut an orange. You always use that similar knife, and your knife will be uh, easily to corrode compared to the knife used for something else. Okay, tarnishing of silver in H2S water leaden air. Tarnishing of silver. Tarnishing of silver ni is about you have a silver ring. Oh, silver ring. You have silver ring here, and you get engaged or whatever. You get married. You get a silver. Not for me. I don't have any silver ring, even though I'm married. So if you have a silver ring, make sure uh, don't don't take it out and put aside. You have to wear it every day because of silver easily to corrode and it's not shine anymore. However, if you wear it, the silver become shine because of what? Because of the corrode, corrode product on the top of silver being washed out, so you can get the pure silver. So it's shining. So another thing is that electrochemical for corrosion is a wet corrosion. This is the wet corrosion which is happen normally in your daily life. This is not very much happen. Wet corrosion is a corrosion. This is a galvanic cell. Due to development of tiny galvanic cell on a metal in presence of moisture, impurities, oxygen, blah blah blah, and normally it's a rustic of iron in a moist environment. If you go to the European country, if you have a car, your car is less corrode compared to your car. You bring the same car in the Indonesia because of what? In Indonesia, our moisture is very high, so your car is easily to corrode compared to your car in European country, because in European country, they in that country is First is very cold. When very cold, the moisture is very less. So your car is less corrode. All right. So the first one is dry corrosion. I have to, because of this the topic of corrosion sign. So this is dry corrosion due to the direct chemical reaction of oxygen. This is if you are rich enough, you can buy this kind of thing. This is the silver bowl plate. Normally people use it. Not normally people use it. Some of people who are rich enough to buy this kind of thing and use it when you have wedding, when you have engagement ceremony, you put, what is that? You put money, you put all the gift on the top of it. Remember this one? I don't know where. I think we have a similar tradition in Malaysia and Indonesia. We have this kind of thing. No, we have. Some people have it. I don't have the money to buy this thing. So this is a silver ring, tarnished silver. This one is polished silver, very shiny. Silver ring should white shining color, not like this. This is not a silver, not this is called the corrode. So this is a dry corrosion. It's happen when uh, uh, oxidative molecule directly contact to the substrate. This one. Okay, but one of the time is this one is one of corrosion by gas. You have silver, you have chloride. Where comes the chloride? Gitu chloride plus chloride gitu to AgCl, and now porous layer. Ferrum, where come this thing? This is come from normally from your soap. Soap you have when you wash your dish, so you come from your soap. If you have silver ring, contact chloride, and you can get gallium chloride, which is this is corrosion of silver. Okay. Okay. This is the mechanism of corrosion by hydrogen evolution. If you have metal, you put into the acidic. So this is acid, this is metal. Any metal, gold except gold. So because of gold is very hard to oxidize. Gold is always reduced. That's why when gold hunter, they can get pure gold thousand years ago from the ancient coffin. Okay, this is direct metal. Then you can just put into the acid. So acid, what is happen? You have a silver, not normally silver. Your what is that? Your pan in your kitchen. Your pan in your kitchen. You make some dishes which is acidic. Let's say asam pedas is acidic. Uh, Anything that acidic, so it can be corrode. So the important thing is in corrosion is a wet corrosion. That is before this is only we can call it a dry corrosion, but this one is a wet corrosion. So wet corrosion is a galvanic system. It's a tiny galvanic system. When metal contact with moisture, air, or any electrolyte medium, always occur at another area. Mechanism involve oxidation reduction process, electron release. This one actually wet corrosion is talk about galvanic. It's the same thing. It's just that sometimes evolution of hydrogen and evolution absorption of oxygen. This is sometimes. Normally, when corrosion occur, hydrogen being released and absorption of oxygen from the environment. So what's new in the corrosion? Nothing new. It's just electrochemical cell. Nothing new actually. This is the basic knowledge of electrochemical cell. Corrosion, you must have 1, 2, 3, 4 similar essential component of electrochemical cell. You must have 1, 2, 3, 4 anode, cathode, ionic conductor, magnetic conductor. What happens if one of the component missing? Corrosion never occur. So corrosion never occur means that you can protect the substrate. So make sure that corrosion never occur. So you have to remove this thing. One of them is enough. So corrosion never occur. So what you can do is that this is a basic knowledge of corrosion. So I think I have another 10 to 10 to 15 minutes. Okay, I will share you this. This is the detail of the corrosion. So just go to make it a little fast. The middle drop, what happened? This one is what happened. This is a corrosion diagram. What happened? I already said it to you just now. This is the chemical part. So ferrum become OH, blah blah blah. So comparison. This one is new. Comparison between wet and dry. So dry corrosion is occur in absence of moisture. Wet corrosion occur absent of moisture. Absent of moisture, or this one should be dry here. Dry should be here. Corrosion, wet corrosion should be here. The other way around. Wet corrosion. This is wet corrosion. This is dry corrosion. This is wet corrosion. Sorry about that. So very slow. Oh, there's some mistakes here. Occur in the absence of what moisture should be here. So this one should be here. Occur in the absence of moisture. Occur in the absence of moisture. Occur in the absence of moisture. Present of moisture. This one is wet, must be present. Present of moisture. Okay, involve direct attack, complete cell is required, rapid process, wet corrosion normally rapid means that the rate of corrosion is very rapid. Very slow process, corrosion occur and not blah blah blah. Process corrosion uniform, depend on the size of penalty. This one is a comparison between dry and wet corrosion. Okay. Factor of effective corrosion. Why the metal corrode? This is factor, nature of the metal. So if your metal, your substrate is gold, it's very hard to corrode. If your substrate is the iron, it's easy to corrode. Pure metal, physical. I will explain to you in the next slide. Okay, corrosion control. Okay, previously I talked about corrosion. What is corrosion? How the corrosion occur? So corrosion can be controlled. Actually, corrosion can be controlled. Corrosion can be controlled. First, if you want to make your things less corrode, don't use metal. Use stainless steel. Don't use pure metal. Stainless steel actually is more rugged compared to the iron itself. If you have an iron bar, and you have a stainless steel is more rugged to protect corrosion. You must have proper design. You can protect your substrate using anode and cathode. So it means that even the corrosion happen spontaneously, you can protect your material to be less corrode. Corrosion will be happen. It just slow down the corrosion process. Or you can paint or coat your material. Why you need to paint or coat? Remember that you have four things. When you coat, you remove the electrolyte. So electrolyte doesn't touch the substrate. So if no electrolyte, no corrosion. So why corrosion is really important? Because economic, safety, and environmental concern. Because economic, people invest so many amount of money to make sure, let's say a bridge doesn't corrode. They put some painting or coating. They put some inhibitor on the bridge structure. Safety. If you don't protect your bridge, it might fall down. Let's say the bridge, if you coat with a good coating, you paint it with a good coating, it can last 20 years. If you don't protect the coating, to protect the bridge, it lasts 2 years maybe. Environmental concern is about, if so many things being corroded, it is not good for environment. Okay, let me move a little bit faster. So this is type of corrosion. I will share this slide to you, and you can have it, and you can have look into it into detail. So this is type of corrosion. There's so many type of corrosion. You have uniform corrosion, and the last one is the alloying corrosion. This is type of what of corrosion happen. This is a uniform corrosion, pitting corrosion. Pitting, they make a hole. This is corrosive corrosion in joint. You have, let's say, this is substrate, and you have put in the joint here. So in this place is a corrosive corrosion. And galvanic corrosion, uh, if you put two dissimilar metal, let's say copper and zinc, you put together, it's become galvanic corrosion, because uh, zinc and copper, they give you different, they give you another, one is become cathode and one become electrode. So I move corrosion prevention. Okay, can we control corrosion? Yes, we can control corrosion. So what we can do is that, this is an 1, 2, 3, 4, 5, 6, a basic control for corrosion. You can alter the environment. And you can change the environment. If the environment is too acidic, let's say you have a reactor, you want to make polymer in the reactor, and your reactor is made from steel, so you have to alter the environment. If your reactor, inside your reactor, you put too high acidic, so it's not good. So reduce the acidity or reduce the temperature. You can alter the environment. You can, how to control corrosion? You can, choose another material. Let's say, instead of using pure metal, you can use an alloy. Alloy and pure metal, alloy is better, because alloy is a combination of few metal. So alloy, some alloy is very, like stainless steel. Stainless steel is very good for corrosion prevention. You can also use cathodic and anodic protection. This is this topic I will talk to you in a bit. Coating in a bit. Proper design, you have need design, and also you can use inhibitor. Okay, let me move to another part. This one is carbon steel. So use a better material, then you get less corrosion. But of course, it's expensive. This is a stainless steel. No, they use stainless steel in the kitchen. So very less corrosion. So it's good for environment. It's good for health too. You can use, but it's quite expensive rather than to use. So if you use only normal steel or normal iron cast is quite cheap. But if you use stainless steel, is quite high. That's the only problem. So you can use cathodic protection. What is cathodic protection? So actually, cathodic protection, okay, cathodic protection, it's like a galvanic cell. Okay, this is this is one of the diagram for cathodic protection. So if you have steel here, pipe steel, you want to protect the pipe steel, you connect with wire, and you put another metal, let's say magnesium. This one is magnesium. So instead of iron here being corroded, so because of magnesium and iron, magnesium is lower in terms of reduction potential. So magnesium will oxidize instead of steel is here. When magnesium is oxidized, the current flow here, electron flow here. So magnesium will release electron, goes to the ferrum. So ferrum never oxidize. So magnesium is oxidized. This is one of the way where they sacrifice. We call it sacrifice electrode. So another thing being oxidized, but protect another thing. So this is a another cathodic protection. So you protect still by using another metal. Another metal will be corrode. Okay, this one impress current. Impress current is another method of protecting the material from corrode. So instead of, okay, this one, okay, I want to compare this one. Instead of you are using another metal to give an electron to iron here, you can use, this is a power supply, rectifier is power supply. You can use power supply, whereas the negative terminal goes into the tank. So the tank is protected because of they don't want to oxidize because they have enough electron. They get enough electron from the power supply, and this one is a so electron. So you have another electrode here. Normally they put platinum here. So this is the setup for another cathodic protection. So your tank being protected by giving your tank electron. So your tank, your iron in your tank, no need to oxidize because they already have electron given by the rectifier. So this is how they protect. This is example of corrosion protection. See, this is the first one is this one. They use ferrum and magnesium. So ferrum give electron to the ferrum. Let's say this is a pipeline. This one magnesium. Magnesium, they put magnesium, they bury magnesium beside the pipeline. So you can put magnesium, but you have a metal connector here, and this one is electrolyte. So they protect this one. Okay, in case of this one, it's a sacrifice. Normally we call it, this one is aluminum nugget, aluminum zinc nugget. So instead of they put here because of they want to protect. It's similar like this. It's just that this is in ship. This is the ship. They stick the the sacrifice metal into the surface of the metal need to protect it. This is another thing they put to protect this pipe. This one. You can do this in your sepeda motor if you need. You can buy some magnesium, but the problem is that magnesium is very expensive. It's to protect your sepeda motor. Okay, this one is impress current. You can use this one to protect this one. Let's say this is a pipeline. You can put some electric into the pipeline. Uh, Actually, I don't know in Indonesia, but in Malaysia you can find this kind of structure beside the pipeline. You know, about 100 meter, they have a one structure like this, and they give current to protect the pipeline because we have quite a long pipeline from Terengganu state to the Singapore. We have a very long pipeline, and along the pipeline, they give some rectifier, some electron, or some current to the pipeline to protect our pipeline. And the pipeline is a transport gas directly from Terengganu to the Singapore. Uh, from uh, from not using the another way of transporting gas is using ship, a very big ship. But another way is that use the pipeline. So we do have in Malaysia, there's a pipeline commute the natural gas from Terengganu to Singapore. And you can find this along the way. You can find this structure, this kind of structure. Okay, this one is we call it cathodic protection. Another one is anodic, because what happened here is normally in the they use it in the station storage tank. Normally happen in the uh, untuk apa? Fill gas, isi minyak like petrol pump. Sorry, petrol pump. So what happened that what happened is instead of giving electron, they take the electron. Okay, instead of this one is giving electron to the system, this system to protect this, they take electron, so make this thing corrode. So another way is anodic protection is make the tanks corrode. So why want to make the tank corrode? Because of if the tank corrode, they produce a layer of oxide film on the surface of electrode. So layer of oxide things is protected actually uh, for further corrosion. So it's protect the surface of electrode. Okay, not too much on this one. So I go to the last part. Dr. Diah, if I have to stop, you should tell me if I need to stop. Is
Okay,
it
I
okay?
think 5 more minutes.
5 more minutes. Okay. Okay. Thank you, Dr. Diah. So another thing, another way of protecting your material is just paint and coating. Paint and coating. You can paint your material. You must have a good design. So design is bad, design is good because of in this part, this is a curve. This one is very straight angle. This is curve. Curve is better because of you can easily to wash it after that. Uh, this one is a design which is good and it's bad. This one is better because if you flow liquid flow here is good. This one is not good because you can deposit something. Okay, and also the inhibitor. Inhibitor actually is same as a paint. It's just we call it inhibitor. This is another way of venture in terms of research. You can produce inhibitor, then test it using electrochemistry. Inhibitor that is actually is a compound. It's a compound. Corrosion inhibitor is substance when added to small quantity reduce the corrosion rate. So you can buy inhibitor. WD-40 actually is very famous in the world. This is kind of inhibitor. You just spray to your material, then it's protect. Not forever, but for a certain time. This one interfreezer. Inside the interfreezer is also inhibitor. Make your tank, your water tank in your car does not corrode. Okay, so I goes to the uh, part C is a corrosion monitoring. So you need to monitor. You know how the corrosion occur, you know how to protect, and you must know how to monitor. So there's a few way of monitoring. So what is the why we need to monitor corrosion? Because of the first one, if you know when the corrosion happen, you can uh, provide early warning to your material when it damaged. So if you know the process of corrosion, you can modify the parameter, modify the environment, identify of them. If you know the corrosion will happen, you can control it. That's why corrosion monitoring is important. So this is a way of monitor of the corrosion. There's so many ways. Actually, more than this. This is part of the ways of monitor. You need to monitor the corrosion. So in the lab, the the easiest way of monitor the corrosion is by corrosion coupon or weight loss. You have a substrate, you put into the 0.5 NaCl for certain time, let's say 1 day, take it out and study the corrosion rate. That's the simplest one to monitor the corrosion. This is the simplest one. So normally, if you want to test the inhibitor, they use this kind of method. They put some stainless steel into the inhibitor, then take it out and study how the corrosion rate. What is the corrosion rate? Calculate the corrosion rate. And this one is used electrical resistance ER. This one is used industry. They put a probe on the pipe actually, then you can get the corrosion rate. Uh, and the thing is that you can use, there's so many methods of corrosion monitoring, but need to monitor the corrosion because of what? Because of we want to know how long is our building, how long is our bridge is lasting. So special monitoring, there's so many things. Then I think that's all. If I want to continue, I think it's not enough time for question. Application of monitoring techniques. You need to monitor for what? For to evaluate the risk. You need to monitor the question for what? For process changing operation condition. You know, in industry, like a petrochemical industry, they don't directly study the corrosion rate. They study what is the hydrogen sulfate, uh, H2S inside the petroleum. They just study that. So if the hydrogen sulfate so many in the pipeline, it means that the corrosion rate will be higher because hydrogen sulfate is a oxidation agent. It's easily to corrode the metal. So they study something else, they get this and they can relate to the corrosion rate. So with that, is the end of my presentation. And you have, thank you very much. If you have any question, and this one is attendance e-certificate. So I share it with Dr. Amalina because of share it with Dr. Amalina with Dr. Amalina with Dr. Amalina. So because of our faculty will provide students and lecturer who are coming here in this presentation to give some certificate. With that, thank you very much. Amalia, sorry, not Amalina, Dr. Amalia.
I have
Okay.
received it, Dr. Noor. Thank you.
Okay. Okay. If you have any question, Dr. Amalia, Dr. Tria, or from the student.
Okay, thank you, Dr. Muhammad. Any question from students? If they don't have question, then you can ask them to check the comprehension.
Like comprehension, why we need to have corrosion monitoring? Is a question. Anyone want to answer? Why do we need a corrosion monitoring?
Hello, students. Ahmad Farhan.
Okay, Farhan, can you answer it?
Thank you for time. My name is Ahmad Farhan. I think why do we need to monitor corrosion is because we need to know how long a building or tools that we use will last.
Okay, good. A good answer. Simple and good answer. Okay. What is different between dry corrosion and wet corrosion? Anyone else?
Hello, student who wants to answer? Muhammad Saki Hudi.
Okay. Thank you for dry corrosion is a common corrosion such as because water droplet dry corrosion. That's wet corrosion. Dry corrosion is the example is dry corrosion is blow a sharpener.
Okay, remember that the analogy that I given to you just now. All right. Okay.
Thank you.
Okay, thank you, Muhammad. Maybe another question. Application of electrochemistry. Give two application of electrochemistry.
Okay.
Anyone?
Yeah. Please mention two application of electrochemistry.
Okay,
Ahmad
Farhan,
Farhan, once again.
Okay, please, Ahmad Farhan.
the application of electrochemistry, such as sensing and energy storage.
Yeah, you're right. Energy storage and sensing. So sensing energy storage is among the famous area right now actually for research and development. So they are, updating the way of sensing some things. Nowadays there's some researcher from I can't remember, but from European country who try to sense the smell. Smell. If you, let's say, you have durian, you can smell durian using the equipment. You can smell something else using the equipment. It's actually is a what happens is a smell of durian. Actually, something from durian evaporate and goes into your nose. Then you can sense. So you can smell it. So this is kind of thing that you can pursue for another level of education. So thank you very much. Uh, I think maybe this is end, Dr. Diah. And I would like to thank everyone here, student, and I do some research on ITS. ITS is one of the I think number one in Indonesia.
Among 5 big university, Dr. Muhammad.
Among 5 big university. I just read the not encyclopedia.
Probably number 1 in East Java.
Maybe
East Java province, yeah.
Number 1. So it's lucky for you student to be here, and your lecturer is very very active in research and collaborating in local and also the outside your country. And I think it's good to have something like this in the future. And if you are interested, just come to our place. If no COVID, not now.
Yeah.
After this, when no COVID, you can have some visit with student from there, and we have another visit from here to there. We can collaborate much more than this. With that, I end my presentation. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Muhammad. And before we close this guest lecture, I want to remind the students who can answer the question, please contact Mrs. Amalia, Bu Amalia ya. We will give you small gift, and please write down your cell phone number.
And another thing, Dr. Diah, don't forget ask student to fill this form.
Yeah.
Okay.
And please don't forget to fill this form so that you will get the certificate. And in Indonesia, especially at ITS, students have to collect the certificates before they graduate. Yeah, they have to fulfill around, I forget, 1,000, not 1,000, now 2,000 I think. Berapa Bu Amalia kreditnya sekarang yang untuk lulus tuh? Berapa?
Saya juga enggak hafal.
I forget. Yes, new. Previously 1,600 I think credits before they graduate.
Oh, that's
yeah,
so much.
for activity. Yeah, for activity, student activity. So probably if they won the championship, then they get around 1,000 credits, something like that. So they have to collect. Yeah.
Banyak
please, please, students who can answer the question, contact Mrs. Amalia. Okay, I think it's already 17 minutes past 9, and this course, this materials chemistry course, should stop at 9:30. So we can stop here. Thank you very much for your attention. Thank you very much, especially for Dr. Muhammad. Thank you very much. And here actually we have our chairman, Dr. Sikit. Hello, Dr. Sikit.
Hello. Okay.
Yeah. Here we have our chairman. Probably before we stop this guest lecture, you can deliver a short speech.
Wow, it's great. Thank you very much for the speaker, Dr. Muhammad Noor Jalil. Thank you very much. So we hope the student has have very interesting lectures from your presentations today. I think that's all. Thank you very much.
Okay, no problem, no problem. It's good to have that.
Yes, and I think all of you have already talked. We're in line what we have already given to the students. Yeah, so we have already, well, in my class, I have already given them like 2 weeks about the introduction. I think 3 times, 3 weeks about the electrochemistry, and it's all in line with all of you have already given. And for the next semester, they also have the corrosion course. Yeah, so you have already given them the background or the introduction to the corrosion.
You mean that, Ibu Diah, you have two separate subjects?
Yeah.
All right, okay.
Yeah.
We do have the same thing, but in one subject. We have 3 credit hours. We call it electrochemistry and corrosion science, which is 3 credit hours, which is 3 times 3 hours per week. So the things that I presented just now is that is a, I can say, short notes, a very short one about the whole of the process, or the whole of the subject.
Yeah, in our department, materials chemistry consists of the analytical chemistry and electrochemistry. Previously, in the previous curriculum, actually this course were from 2 different subjects. Yeah, the analytical chemistry 3 credits and the electrochemistry through 2 credits. But now, at the new curriculum 2018, because of many different changes, so we combine the 2 courses into 1 course, the materials chemistry, 3 credits, including the practical works at the laboratory.
All right. Okay.
Yeah. So yeah, this what you have already talked really support to the materials, the course materials in our class. Yeah. Okay. Thank you very much, Doctor. Doctor again. So this is like a wish that Mrs. Amelia soon to get the doctor because she's still in the master degree. So soon to be the doctor.
Bismillah.
Soon to be, inshallah.
Yeah, amin. Yeah. So before we leave, probably you can help to take the picture.
Yeah, Bu Diah. Maybe all the participants can
turn on cam.
Video.
Yeah, turn on the cam, please. Ready?
Yeah, wait. Gallery. Wait, I have little problem. Dr. Noor, could you please stop the share screen first?
All right.
I don't know why.
Yeah.
Give me a second.
Okay.
Yeah. Stop share.
Where is it? Stop sharing.
Yes.
Stop share. Okay dah. Okay.
Okay, there are 4 slides. So the first slide, 1, 2, 3, smile. Okay. Wait for the second one. The second slide. Oh, there are many students has turned on their video. Okay. Finish, Dr. Diah. Thank you.
Thank you very much. I think we have already finished. See you next time with other guest lecture. Thank you very much once again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Dr. Noor.
You're welcome, you're welcome.
Makasih ya, Bu.
Sama-sama. Sudah ada yang ini apa? Memberikan nomor telepon.
Belum.
Berarti
belum.
mereka nggak mau ya?
Belum. Siapa ini? Belum, Bu.
Tadi yang jawab mau nggak pulsa? Kalau nggak mau ya nggak apa-apa sih.
Ahmad Farhan sama siapa tadi saya ini?
Iya. Oke.
Mau, Bu.
Mau. Menghubungi Bu Amalia ya. Kasih nomor teleponnya. Mungkin nanti dapat pulsa 10.000. Oke ya.
Geng.
Live ya sis ya.
Geng. Makasih, Bu.
Sama-sama.
Pak Hanif.